Page 314. Chapter 5. Rate of change and slope. Rate of change. Shows the relationship between two changing quantities when one quantity depends on the other. The following is true. Rate of change is equal to change in the dependent variable divided by change in the independent. The dependent is the y. Which means the independent is the x. Good. So all rate of change really is you change in the y values divided by your change in the x values. Okay? So don't let it scare you. It'll be okay. Look at problem 1, finding the rate of change using a table. The table's got a 1, 2, 3, 4. Table's got a 1, 2, 3, 4. And it's got a 260, 520, 780, 1040. What are these values going to represent? This is time. This is distance. But isn't that your x and your y? Okay. So your rate of change is going to be take 520 minus 260 and divide it by 2 minus 1. $520 minus 260. 260. 2 minus 1. What's your rate of change? 260, right? Every unit of time that increases once, your distance increases 260. That's fast.
That's always the first two things in the y and the x. It's always the first two numbers that you do the equation by.
Yes, or you can pick any two.
And you still get the same number.
Yeah, if you took your 1040 minus your 780 and your 4 minus 3, you're still going to get 260.
Okay.
If you took 1040 minus 520, you would divide that by what?
4 minus 2.
Yeah, 4 minus 2. Do it. I'll do the bottom, you do the top. I'm done. I bet it's...
I'm doing this. Nobody do it.
I'm done. Right?
Because you have to.
No, because I knew it was going to equal 260, so. Because that was the rate of change. Clear? Alright, good. Look at the top of page 315. The graphs of ordered pairs, time and distance in problem 1, lie on a line as shown at the right. The relationship between the time and distance is linear. When data are linear, the rate of change is constant. Notice also that the rate of change found in problem 1 is just the ratio of the vertical change to the horizontal change between 2 points on a line. The rate of change is also called slope of a line. So slope is the same as rate of change. Okay, so slope is also change in y divided by change in x. Okay, your change in y divided by your change in x. It's also referred to as rise over run. Okay, rise over run. So look at problem 2, finding slope using a graph. If you're going to find the slope of a line using a graph, that's the easiest way because you can just count. If you got a graph and this is 2 and 4, negative of course, 2, 4, 6, 8, 2, 4, 6. And let's take a line and try to get it through like there. Undo. You have to find the slope of that line. The easiest way to do it when you're sitting on a graph is to just count your rise and put it over your run. So rise is your vertical change. Alright, so to get from this point, let's say we're going from here to here. How many do you got to rise here? How many do you got to rise? How many do you got to rise? Good. We're at 0 on the y-axis, and we're rising up to here, so we're rising 6 units. So our rise is 6 over our run. How many do we got to run? We're running from -4. We're running 4 units. So our rise over run is 6 over 4, which simplifies to 3 over 2. Okay? Alright, we've got to find the slope of the black line. We're at 2, 4. Okay. We're going to rise how many? We're going over to this point right here. We're going to rise 4, and we're going to run 4. Now, look, this is important. You're always going to rise. Okay? But if you run to the right, your run is positive. If you run to the left, your run is negative. So this rise is 4, and this run is -4. You always rise, so your rise can always be positive. But when you run right, you run positive. When you run left, you run negative. You're going to have to be quieter with that or not do it anymore. Okay? Go ahead. Can you ever?
Rise down?
No. You don't. That's why you always rise. Okay? You always rise. Your rise is always positive, but if you run right, it's positive. If you run left, it's negative. Okay? Lines that go up and to the left have a negative slope. Lines that go up and to the right have a positive slope. Okay? Everybody all right with that? So look at the bottom of 315, the got it. You got 2A and 2B. There's two graphs there. The got it 2A. How many do you rise in that picture? How many do you rise in that picture? You're going to rise 2, and you're going to run 1, 2, 3, 4, 5. You're going to rise 5, aren't you? So what's the slope of that line? 2 over 5, or 2/5. Do you see it? Confused? You're trying to get from one distinct point to another distinct point on the graph. So if you're at that point, that point is at -3, 1, right? Let's see, so -3, 1 would be about here. And then the other point is 2, 3. So 2 and 3 on that graph. So there's a line we're looking at, right? You're going to rise until you are perpendicular to the point you're going to. So you're going to rise to here, and you're going to run here. This always wants to be a 90-degree angle. All right? So if this point is at -3 and 1, and this point is at 1, 3, then look at your y's. You're going from 1 to 3, aren't you? So you're rising 2. Okay? Now you're running from -3 to 1. So you're running how many units? No, to 2, I'm sorry. You're running from -3 to 2, so that's 5 units. So you're rising 2 and you're running 5. So your slope is 2/5. Look at the second example. How many are you rising there? 2. How many are you running? You're running 6. Alright, so your slope's 2/6. Now, positive or negative? Negative. And 2/6 simplifies to 1/3. So your slope of that line is -1/3. Turn the page. Alright, finally they're giving you, you're going to have to find the slope when you're given the coordinates. Okay, so slope also is equal to this. Slope is equal to y sub 2 minus y sub 1. That's your change in y. Difference in your y values. X sub 2 minus x sub 1. It's the same thing as your change in y over your change in x. Okay, if you're asked to find the slope of a line that has these 2 points on it. Alright, first thing you do is you label them. This is x1, y1, and x2, y2. And then you plug them into the slope formula. So the slope of this line is going to be equal to -2 minus 0 divided by, and here's where you got to be careful, 3 minus -1.
Oh, yeah, it's x.
You're subtracting. So -2 minus 0 is -2. 3 minus -1, that's 4. -2 over 4 equals -1. and that's slope of a line. Any questions? Page 318. Six and 7. 10 through 16. 10 through 16. 20 and 21.